In the second video for empirical formula, we're going to take a look at some other types of questions that we might encounter. So sometimes we're not given percentages at all. We're just given the amount in grams or maybe even just in moles. So when you're just given the amount in grams, just start step 3 of our process and convert directly to moles. So for example, find the empirical formula of a compound that has 24 grams of carbon, 4 grams of hydrogen, and 32 grams of oxygen. Well, carbon, if we have 24 grams, well, let's just convert that to moles. Divided by 12 grams per mole, well, that gives us 2. Hydrogen, 4 grams divided by 1 gram per mole, well, that gives us 4. And, let's move this down. And then, let's move over here. And then we have oxygen. We have 32 grams, 16 grams per mole. That also gives us 2. So we have 2, 2, and 4. But that's actually not the lowest whole number ratio. So we have to divide by the smallest, which is 2. 2 equals 1, 2, 2, 1. So therefore, our formula is CH2O. That's our empirical formula. So it's actually a lot easier if we just have the amount in grams. We don't have to do any conversion between percentages and grams. And if it's moles, well, then we just divide by whatever the smallest number it is. Let's look at going from empirical to molecular formulas. Now, since the empirical formula is the lowest ratio of the actual molecule does weigh more. And it weighs more by a whole number multiple. We have to try and find out what that multiple is. So we divide the actual molar mass by the mass of 1 mole of the empirical formula, and that gives us our multiple. I'll show you what I mean in a second. So, for example, we have just a regular empirical formula problem. We have caffeine, and it's 49.48% carbon, 5.15% hydrogen, 28.87% nitrogen, and 16.49% oxygen. I want to know its empirical formula first, but then I'm giving you extra information in that caffeine has a molar mass of 194 grams, and I can use that to find its molecular formula. First, I have to find the empirical. So we have to assume 100 grams, and for carbon, we have 49.48%. Gives me 49.48 grams divided by 12 grams per mole. And that is going to be, my trusty calculator here, 49.48 divided by 12, 4.12. I'm going to have hydrogen. 5.15% gives me 5.15 grams. Extend my page. Divide by 1 gram per mole gives me 5.15. Nitrogen is next. 28.87%. 28.87 grams divided by 14 grams per mole. Gives me 2.06. Oh, I have to extend my page yet again. And I have oxygen, and it is 16.49%. 16.49 grams divided by 16 grams per mole. It's going to be 1.03. So 1.03 is the smallest. Gives me 1, 1.03, 2, 1.03, should be 5. And this is 4. So in the end, my empirical formula is C4H5 N2O. So that gives me halfway there. But I still have to figure out what the molecular formula is. And I have this molar mass here. So let's go on to the next page. So my empirical formula is C4H5N2O. And that has a mass of 97, right? Yeah, 97 grams per empirical mole. So the molecular mass is equal to 194. So to get the multiplier, I just divide the empirical mass over the empirical formula mass, and that gives me 2. This is my multiplier. So to find out the molecular formula, it's going to be the empirical formula times whatever the multiplier is, in this case 2. So it's C4H5N2O. So that becomes times 2, CH10N4O2. And that's how I figured out my molecular formula, which is quite a bit bigger than my empirical one. So those are a couple more examples of different types of empirical formula questions that you might see.